Okay. Yeah. Anyways, what's the inverse? Okay, if not this, then not that. If not Barshan, then not Oklahoma. Is that true or false? False. If you're not Barshan, sounds like an arrogant statement. If you're not from Bartlesville, then no, from Oklahoma. Yeah, that's false. So just because the original statement is true doesn't mean the converse and inverse are going to be true. Sometimes they are. If the original statement and the converse are both true, it's a biconditional statement. You can connect with if and only if. Do you guys remember what the last one's called?
Contra. We swap them and not. So if not, okay, then not.
Yeah, you do both. You swap the order and you make them both not. So if you're not Oklahoman, then you're not Barshan. Is that true or false?
True.
That is true. The original statement and the contrapositive are logically equivalent. If this is true, this is true. If this is false, this is false. Same thing with these two, actually. These two are contrapositives of each other, but mostly we just talked about these two. All right. What did Modus Ponens mean? Okay, it was...
you can't tell for sure.
No. Okay, it meant if I said Will is Barshan, then what can I assume? He's from Oklahoma. So that's using Modus Ponens. Modus Ponens is basically just using the if-then statement. Okay, so it's kind of like saying somebody is Barshan, therefore we assume they're Oklahoma. That's just very basic Modus Ponens. Modus Tollens is using the contrapositive. So if I said Bob is not from Oklahoma, therefore what can we assume? Or what do we know? He's not from Bartlesville. Okay, that's using Modus Tollens. So there's always the not thing in it. So using the original if-then, that's Modus Ponens. It's kind of in alphabetical order, right? Ponens goes with the original. Tollens goes with the contrapositive. P before T, original before contrapositive.
So then what if it's just
It's not always P before T though. P.
Well,
Can you just Jordan forgot? Wow. He says he doesn't even remember talking to you.
I know. I must have been thinking of something else when you were saying something.
My dad thinks that.
Usually when people ask me to go to the bathroom, I say yes without even acknowledging that I had the conversation. Yeah.
Did you start?
Oh, I remember what I was going to say.
Wait, Mr. Jordan, did you start?
Yeah.
Okay, good.
Here, let me turn the volume. Maybe that, I can't, volume's maxed. I'm not sure.
Get a camera. You get a whole YouTube channel, so you need a professional camera.
You need to get more
You
subscribers.
You can buy that for me for Christmas, all right?
We all should put our money.
You need to pursue your YouTube.
My YouTube career. Okay, Jaden, I said you can make a page of notes to use on the final. The final for math is Tuesday. So, I don't know if you guys remember last year, but some of you weren't here. On the finals week, we only go to noon, so that's good news.
Yeah.
On Monday, I don't remember if we did this part last year. Like 8 to 10, I think we're going to our normal class, like first and second period, like normal. And then at 10 to noon, you're taking your Bible test. In, I don't know, probably, what do you guys, Bible 2? Probably Mrs. Plummer's classroom.
That's on Monday.
Next week. That's Monday.
And then what all do we do Tuesday?
And then Tuesday, at 8, you're taking this test in the Oasis room with Mr. Totino, I think. Huh? Science is last.
So it's like, it usually is.
It's the same as last year. Okay, and then at 10 o'clock on Tuesday, you're taking social studies. With, what's your social studies called?
Government.
Government, that,
Wait, Tuesday's English in the morning?
that is with me, but it says high school 5.
Oh.
I think this is not updated, so this might be wrong.
Wait.
Well, no, that's the name of the classroom. My classroom is
Well,
called high
there's
school
fifth
3.
period and there's seventh period for.
Did you say Tuesday?
Anyway, Tuesday at 10, you're taking social studies.
What's Modus Ponens again? Fifth period game.
And then on
Modus Ponens.
Wednesday at 8, you're taking English with in Mrs. Plummer's room again.
And then we take. What day? You said Wednesday? I think English and
Wednesday at
science
8.
all have to go.
And then at 10 o'clock, of course, that leaves science.
Wait, did you say that Tuesday math in the morning?
Huh?
Tuesday math in the morning?
Tuesday is math, yeah, 8 o'clock. Science, what class are you guys in?
Probably the
First year.
Is it called biology?
Yeah.
Okay, it says Mrs. Plummer again, so you guys are gonna be all.
No, we're just biology. We're not.
Okay, some of that, what I said might be a little bit off because this is not the newest version of that. But most of that's probably right.
You can never tell though.
Yeah,
After the final each day, do we just go and we're going five?
you're going home at noon.
Wait, we're going home at noon? Yeah, we didn't have
Oh
days.
my gosh, how many times? New kids.
Wait, so we're going home?
Yes. Unless you have sports.
Unless you have sports. Alright. Are you in basketball? Not pretty. Well, you probably get out of basketball early though.
Well.
You think you're gonna have like a 3-hour basketball practice, 4 hours, whatever it is? Okay. I forgot what we're doing. Number 13, A.
Wait, what is Modus Ponens?
Modus Ponens is using the if-then statement,
Then blank, right?
I guess. Okay. A says, I am, okay, the original statement, if I study, then I learn. Okay, that may or may not be true. We're not going to argue about that. A says, I am studying, therefore I am learning. What kind of logic is that? That's Modus Ponens. It's kind of restating the if-then statement. B, I am learning, therefore I am studying.
Assuming the converse?
Yes. And you're not supposed to assume the converse. That's like a false kind of logic. So, like we talked up here, like this converse is not true. So anyway, yes, it is the converse. 3, option 3. C, I am not learning, therefore I am not studying. Modus Ponens, it's the contrapositive thing. And then D, I am not studying, therefore I'm not learning.
Assuming the inverse.
Assuming the inverse, that's also a false assumption.
I don't think studying just helps you learn all the time. Sometimes, like, and it helps you for sure. Just like sometimes.
Okay, yeah, so option 5 is fine. Number 14 we did not do, so we're skipping that. No. We didn't talk about biology. Yeah, we're gonna finish this today and then we'll start on chapters 4 through 6 tomorrow. Okay, number 2. Let's see how many of these you guys remember. On Friday, I'll try to go through like the like any theorems or postulates you might want to write down in your notes. So Friday we'll probably kind of try to wrap things up. We're not going to meet on Monday or anything, so Friday will be our last normal day-ish. Okay. Number 1 says if AB equals XY. What does AB mean?
One segment.
It's the length of a segment. So it stands for some number. AB could be like 10 inches or something. AB equals XY.
So, did you say the length of ABCs?
Okay.
Is congruent to
Oh.
Yes. If their lengths are the equal, then the segments are congruent. That's the definition of congruent segment. So we're going to say segment AB is congruent to segment XY. What's the difference between equals and congruent?
Here it means so. Wait.
Equals is measurement.
Equals is for numbers. Yeah, it's some kind of measurement. And congruent is for things. Like means things are the same. Equals is used for numbers. So I usually skip this, like saying AB equals XY, and then they're congruent, or if they're congruent, then the lengths are equal, because it's kind of a little too obvious. So I don't usually do that, but the book does. Okay,
So
B.
like one McDonald's can be congruent to another McDonald's, but they don't necessarily.
They're not equal because equals for numbers. If the
I'm saying
two,
they're congruent because they serve the same stuff, but then they.
or maybe they serve, they make the same amount of money or something like that. Yeah. Okay, on B, it's kind of the same thing, but in reverse order. So if the measurements of angle X and Y are equal, then the angles are congruent. Angle X is congruent to angle Y. That's what it means for angles to be congruent. Definition of congruent angles.
It's like definition of congruent angle.
No, that's what they wrote. I was just reading it. Okay, C. This one, I don't know. You might not remember ever writing it, although we did a few times. But you can kind of just, sometimes you can just say something, you can figure out what to say because it's kind of obvious. But C is a theorem that's kind of an obvious one. J and K, angles J and K are right angles, so angle J is congruent to angle K. All right angles are congruent. That was a theorem, not a definition. Definition of a right angle is it equals 90. Not the all right angles are congruent. Chapter 2 was the chapter where we learned,
All the short.
we're practicing for theorems, triagrams, that kind of thing. And then D, point M is in the interior of angle KLN. What do you think it means that the point is on the interior of the angle?
It's in between.
Yeah, somewhere in the middle here. What was it, M? Okay, I think I heard somebody say the answer. Aiden, was that you?
KLN.
Okay. Aiden, what did you say? Yeah, he said angle KLM plus angle MLN equals what? Okay, that's the big angle, the two little angles. How did he know to do that? What? No, he didn't study. He remembered, but what tipped him off that that's what we're supposed to write? It says angle addition postulate. Addition. So what adds up to what? These two little angles add up to the big angle. That's what we just said right there.
Are all of these like theorems and everything in the book?
Yeah.
Somewhere?
Yeah, they're all somewhere. I said on Friday I would try to tip you off any ones that I was concerned about that you needed to know.
Here, I'm gonna write those all down.
Yeah, this is all chapter 2 stuff. Well, actually some of it might be chapter 1. Alright, so on 16 is a actual proof. They filled in about half of it. It's kind of an algebra problem really, that they turned into a proof statement. We're supposed to, okay, if you read it, it says if X, Y, Z. What the heck does that mean, if X, Y, Z? It means that Y is on the line between X and Z. Just like the picture shows. And XZ is 24, then A equals 8. In other words, they're saying we're supposed to prove that A equals 8, which is what they wrote on the 6th line, the last line. Okay, they wrote the given for us. Okay, how do we know that XY plus YZ, I'm on line 2 by the way. How do we know that XY plus YZ equals XZ? Yeah. Yes, okay. The book called it definition of between, which I did not like. So I called it segment addition postulate. Just like we had angle addition postulate earlier, the two little segments add up to the big segment. So segment addition postulate. The last books we used called it segment addition postulate. I thought it was much better. Okay, line 3, their only hint they give us is substitution. What does substitution mean? It means replace. So what are we replacing on line 2 with what, Will?
In number 1, it gives us xy equals 3a minus 7, so we can replace that. And then we just add yz equals 15 minus a, so we can put that 1.
So yeah, what they did is they replaced the xy with 3a minus 7, the y, they turned it into an algebra problem basically. xy equals 3a minus 7, yz equals 15 minus a, and xz equals 24, all that stuff from the given. So they replaced all those segment things with the numbers and letters. So 3a minus 7 plus 15 minus a equals 24. Okay, how did they get from this to 2a plus 8 equals 24?
They subtracted a.
Okay, yeah, the books usually call that simplifying. So for the next line, just put simplified, I guess, for line 4. Then how did they get from 2a plus 8?
They subtracted 8.
They subtracted 8. What's that?
Subtract.
The addition thing?
Yeah, they didn't call it the subtraction property, they called it the addition property, because subtracting 8 is the same thing as adding negative 8, so anyway. They call it the addition property of equality. Means you can add both the same value both sides of an equation. Addition property of equality.
Division property of equality.
Kind of, yeah. The last book, like I said, the last book we had, they did call it division and subtraction, property of equality. This book calls it, yeah, 5. How did they get from line 5 to line 6? What did they do?
Divide.
They divide by 2. Dividing by 2 is the same thing as multiplying by 1/2. So they just called it, they didn't call it division property of equality, they called it multiplication property of equality.
I don't like that.
I don't particularly either, but if you put division property of equality on the test, I would count it right. So
Think of it as you're always adding something instead of subtracting. So you'll be either adding or multiplying, so you're making it bigger. No matter what, you're making it bigger, not smaller.
Is it like Scantron sheets where they'll give you like an answer, you're like test with all the questions on it, and they give you a Scantron or something like that?
no, it's not gonna be scammed. Definitely not.
It's like a normal test.
In about April, we'll take a standardized test, which is like Scantron.
We do it every year.
What about ACT prep?
We're still
When is it?
Snap
I
flash.
have no idea.
What is that? Like August?
It said April.
Oh, April. What is it though?
I don't remember what it's called. It's just you do every Sunday. It's called standardized testing. Is what it is. Okay, guys, if I wanted to find the number that's right in the middle of two other numbers, how do I do it?
You add and then divide by 2.
Okay, yes. What's that called? Adding and dividing?
That's finding the
Average. Okay, finding the average. So if you look at number 17, it says find the coordinate of V. Oh, I didn't read that very well. Anyway, I didn't read it very well in the other class. Find the coordinate of V if W is the midpoint
You just add and then
of UV.
you add and then multiply.
So in other words, we got negative 14 way out to the left. 27, the coordinate of W is in the middle. And then V is way out here. Will, what do you think?
Turn 14 into absolute values and add them. So you know exactly how much space is between them.
Just add to
Okay, he's saying find the distance from here to here, and then add that number on to the 27, right? That's what you meant? That would work too. Do you guys remember how to find the distance between these 2 points?
You just add.
How far is it from negative 14 to 27?
That's 14 plus 27.
No. How far is it from negative 14 to 0? 14. How far is it from 0 to 27? 27. So it's 27 plus 14. 41. So if you just go 41 this way, that will tell you where B's at.
That's what I was saying. Like,
Okay. I didn't. Anyways. Another way to find the length between, like how would I find the distance from here to here? Subtract. We could have subtracted on this one also. 27 minus negative 14 is basically 27 plus 14, which is 41.
that's what
That's what we did.
Yeah, we did that back in the chapter. To set this up algebraically, negative 14 plus V divided by 2 should equal 27. The average of negative 14 and V should be 27. And you multiply by 2 and add 14. So I'm just explaining a different way to do it. This one's probably more intuitive right here. Just so 27 plus 41 is 68.
So we have to do 27 plus
18. So once we get done with 21, we'll be done for today. Got about 25 minutes. We got plenty of time. But 18 is a proof. Oh no, panic. Panic time. 18, supplements. We're supposed to prove supplements of congruent angles are congruent. What on earth does that mean?
That's a good question.
Yep.
Can I go down to the gym now?
Yeah. Supplements of congruent angles are congruent. Are you the only one in choir?
In here, yeah.
Opposites?
Okay, what's a supplement? What's supplement mean? Supplementary mean? Adds up to 180. So if you look at that picture, you see how 1 and 3 look like they would add up to 180, and 4 and 2 look like they would add up to 180 because they make a straight line together. So 3 and 1 are supplementary, 4 and 2 are supplementary. And it also tells us in the given that angle 1 and angle 2 are congruent. So they're saying that if 1 and 2 are congruent, then we're trying to prove what? 3 and 4 is congruent. Basically, the supplements of 1 and 2 are congruent. 3 and 4 is congruent. So our last line should say like angle 3 is congruent to angle 4. Then we're done. They were nice to us and they told us, or they wrote the given down for us. Okay. So here we go, ready? If angle 3 and angle 1 are supplementary, then what can I say about angle 3 and angle 1? They add up to 180. So now, when the book does this, they would put a little m right here, like the measurement of the angle. I kind of cheat and don't do that. I just put angle 3 plus angle 1 equals 180. What else would go with that line? Angle 4 plus angle 2 is 180. And what am I going to write for the reason? Yeah. That's what supplementary means. It means they add up to 180.
Can't we say that you know
Then-
angle 1 and angle 2 are congruent, we can do angle 3 and angle 4 are congruent?
Well, that's what we're trying to get to, but no, we're not ready to just say that right now. Okay, what you're doing is in your brain, you kind of know it's true, but you writing a proof is being able to say it step by step, reason by reason, how we know for sure it's true. Okay, anyways, anybody know what comes, got an idea what comes next?
Well, they both equal.
Well, no, we're not ready to say that yet.
180, then we.
If they both add up to 180, then
They're congruent, so.
if both of these add up to 180, they're equal to each other. So the next line is angle 3 plus angle 1 equals angle 4 plus angle 2. What trick did we just use? Substitution. We replaced 180 with one of those things. Substitution.
So then they're.
Okay, part of the given, this, we don't really need to write this part down, but was that angle 1 and angle 2 were the same?
So the numbers have to be the same.
Yeah, but how do we say that? So what we're trying to get to is say that 3 and 4 are the same.
You take away
You- Did you say that? What'd you say?
take away
You take away 1 and 2. So what are we doing? What do you mean by take away?
Subtract.
Subtract. Subtract.
So then.
Measurement of angle 1, whatever it is, since these two are equal, you can subtract the same value on both sides. What's that called when you subtract the same value on both sides? Addition property of equality. There you go. Angle 3 equals angle 4. And what did we use? Addition property of equality.
And we got what we're trying to prove.
Yeah, we were trying to prove they're, well, technically we're trying to prove they're congruent. Like I said, I kind of skipped the measurements are equal and just say if they're equal, they are congruent. But anyway. That's it. That's what we're trying to prove. 19. That was the hard part. We're done with the proof. All right. Number 19 says transversal. You guys remember what a transversal was?
Goes over multiple planes,
No.
multiple lines.
Usually look something like that in our picture.
Yeah.
But that's, I probably should draw it on a smart board.
Splash zone.
You're gonna splash them.
No.
You should have like plastic covering you if you sit up here. The other day, like when I was driving up to school, I heard this really loud, like thunk. I was like, what the heck? Did I like run over a rock or something?
Just kidding. Did you remember?
No, I looked over on my windshield and there's like a splatter on it like this big. It's like a train. No, bird poop.
Oh.
Oh. That was today?
No, was yesterday. It's still on there, you guys can go look at
My
it.
grandpa did
Get your
work
phones
with
out
a-
and take
with a
pictures.
car before.
It was a Mr. George went to school with Nancy first.
It's like, well, that must have been like an eagle or something. No, it's
Oh,
bird.
dude. Did you see
My
the
grandpa
baby?
had a
Did
turkey
you see
with
the
his
baby
car
on the
before.
windshield?
Okay, anyways, that's not. Okay, yeah, I remember what I was doing. Parallel line, well, if these, I don't like that line. If these lines are parallel, what do we know? What are,
They'll never cross.
what are 1 and 2 called?
Oh.
Corresponding. If the lines are parallel, we know like corresponding angles are the same, right? What is 2 and 3 called?
Interior.
Alternate interior. Alternate interior are gonna be the same if the lines are parallel. Or we could say it the other way. If the alternate interior angles are congruent, lines have to be parallel. What are 3 and 4 called? What do we call those two? Call them consecutive interior. They have to add up to 180 if the lines are parallel. Remember what 1 and 3 are called? Vertical angles. Those are always the same. What are 2 and a linear pair? They always add up to 180, right? So really all these angles are like the same or add up to 180. They're all congruent to each other or supplementary. Okay, anyways. A says if a transversal is perpendicular to one of 2 parallel lines, then what?
It's perpendicular to the other.
Right. If this is 90 degrees, this is 90 degrees. So the answer is then it's perpendicular to the other line. Then it's perpendicular to the other.
What's the answer?
Then it's perpendicular to the other. If it's perpendicular to one of 2 parallel lines, it's perpendicular to the other.
What would 2 and 3 be
Hmm?
again? Can you just
Oh,
repeat
2 and 3 are called alternate because they're alternate sides of the transversal. Interior because they're between the parallel lines. Alternate interior.
Alternate interior. And would it go like if there was?
And again, if you forget, remember the trick. If it looks alike, it probably is. That doesn't always work, but a lot of times. So 2 and 3, see how they look the same? Like they're both obtuse. They're the same. These two do not look the same. They add up to 180. But anyways,
And what
Wait,
was
Mr.
the term
George,
again?
what was? Would it still count like the alternate interior thing if there was a number below the 1? Like say 5 was underneath the 1. Would 4 and 5 be?
yep, 4 and 5 are alternate interior.
No, that's.
Okay.
What completes.
B, if 2 lines are parallel to the same line, then what?
They're all parallel.
Well, yeah, but let's say that in a bit different way. If this line is parallel to this line and this line is parallel to this line, well,
So
it's a little bit different than that. It's not quite transitive, but we're not going to write transitive anyway. If this is parallel to this and this is parallel to this, then these two are parallel to each other, right? So we're going to put, then they are parallel to each other. If 2 lines are parallel to the same line, comma, then they are parallel to each other.
For the term, would it be like the?
P-A-R-A, it's written on line B.
Then they are parallel to each other.
Can you repeat it?
Then they're parallel to each other.
Would it be like the
He didn't know what you're
x
talking
equals
about.
y equals z, so therefore z equals x?
No, that's different. That would be if line A is parallel to line B and line B is parallel to line C, therefore line A is parallel. This is different. This is more like A is parallel to B, C is parallel to B. It's pretty close, but it's a little bit different.
Also, what was the theorem for A?
Then it's perpendicular. Come on, guys, keep up.
Just perpendicular line?
Then Will, you're the one that said that one.
Perpendicular to the other
I
line.
thought that was just
That's
the completion, not.
Yeah, you were completing it. That was the answer.
So we're not playing the theorems?
No,
What we're writing is the theorem. What you said was the second half of the theorem. Okay, C. Non-vertical lines are parallel if and only if. Okay.
Horizontal.
Well, why did it say non-vertical lines? Vertical lines can be parallel, but the reason they said non-vertical lines is because vertical lines don't have any slope. So basically what they're getting at is, what do we know about the slope of parallel lines? Same. So non-vertical lines are parallel if and only if they have the same slope. They have the same slope. They said non-vertical because vertical lines don't have slope, but vertical lines would still be parallel.
Is perpendicular not touching?
Perpendicular, no, parallels don't touch. Skew don't touch.
Oh.
Perpendicular create 90-degree angles. Okay, so on D it's asking about, basically it's asking about slopes of perpendicular lines. Do you guys remember what we learned about slopes on perpendicular lines? They're opposite reciprocals. So if like one of them's 3/4, the other one's -4/3. So D is, they're perpendicular if and only if they are opposite, if the slopes are opposite reciprocals. If the slopes are opposite reciprocals.
If the slopes.
Well, they wrote the if, so
So,
their
slopes are opposite.
their slopes are opposite reciprocals.
are we only gonna have one more packet after this? And what do we do?
Yeah, we'll work on the other packet
Their slopes are wet.
Wednesday and Thursday, and then Friday we'll just like, I'll talk about what's on the test. You guys can work on your page or whatever.
How do you spell
We'll
reciprocal?
like,
How do you spell reciprocal? Oh. Is that nice?
Oh, yeah.
Ah, right.
okay. 20. Okay, we kind of already talked about 20. Jaden, you know what angle 1 and 8 are called? Shh. Exterior is part of it. Why are they alternate? Because they're on opposite sides of the transversal T. So alternate exterior angles. You just write alternate exterior, that's good enough. I assume you know their angles. Trevor, what's angle 4 and 5 called?
Alternate interior.
Alternate interior. I really like number 20 for a question on the test. So it might, or not, maybe not 20, but like a 20's cousin might show up on the test. Let's see, angle 3 and angle 5. Probably maybe ask you to name them, and then maybe the problem right after that. Ask you like to find the missing angle, that kind of thing. 3 and 5 are, well, they are supplementary, but that's not what they're called. Consecutive interior. Consecutive interior.
Wait, is it not? Wait, never mind. It's not. What number are we going to?
Well, we're finishing the packet 21.
Oh. On that front page.
3 and 5. 2 and 6. What's 2 and 6 called? Corresponding. Corresponding basically means the twins in the groups. There's 4 angles up top, 4 angles on bottom. 2 and 6 are the bottom right angles. They're twins. Okay, 20, last one, 21. We're supposed to find the measurement of angle 5 if the measurement of 6 equals 4 plus 1, and angle 4 equals 3x plus 4. Okay, how are angle 6 and angle 4, Dylan, related to each other?
4 and 6.
Yes.
They're consecutive integers.
Yes. And does that mean they're the same, or what does that mean about them?
Yeah.
No. Okay, you see how angle 4 is like a little acute angle? And angle 6 is a big obtuse angle? So they are not the same. They are supplementary, which means what?
7x plus 5.
They add up to 180. 4x plus 1 plus 3x plus 4 equals 180.
Oh. Minus 3.
Minus 3.
No.
Oh, wrong thing. Adding together.
Okay, they're on the same side, so you just put them together.
So,
What do I mean by side? I mean on the left side equals 7x plus 5 equals 180.
minus 5.
I was going to let you guys do that, I guess, okay.
And then 175. And then
Divide by 7, 25. So then you just plug in the x back in.
Okay, is 25 the answer? No, we're looking for angle 5.
Put it back into
Put it back into angle, let's put it back into angle 6, which is this one right here. So what's 4 times 25 plus 1?
Yeah, but if you put it in the other one, it's
Yeah, it matches.
Oh yeah, you could do that too. Angle 4 and angle 5 are the same thing, right? So we probably should have done that one. So 3 times 25 plus 4, 79.
What? Do we turn this in? Sorry, I thought we
No, do not turn it in.